In this problem, we have a car that's racing to beat a train across the tracks. This is a bad idea. Don't try this at home. It's very dangerous. The train is traveling at 105 feet per second. The car is traveling at 95 feet per second. And the car is 30 meters away from the tracks, and the car and the train are 40 meters apart horizontally. We want to find the velocity of the train relative to the car, and will the car cross the tracks in time? First of all, let's write these velocities in vector notation for our car and our train. For the velocity of the car, we simply have that it's going 95 feet per second in the I direction. The velocity of the train has two components, the x and y components, and because we have 40 meters here and 30 meters here, it's at an angle that's a 3, 4, 5 triangle. So we can say that in the x direction, we're going 4/5 of 105 in the I direction, plus, because it's positive y direction, 3/5 of 105 in the j direction. We want to know the velocity of the train with respect to the car. This would be equal to the velocity of the train minus the velocity of the car, which would be equal to, if we solve these down, would be equal to 84 in the I direction plus 63 in the j direction minus 95 in the j direction. Collecting same components, we get that this is equal to 84 in the I direction plus 63 minus 95 in the j direction, which is equal to 84 in the I direction minus 32 in the j direction. Its magnitude is equal to the square root of the sum of the squares, which is equal to 89.9 feet per second. The angle at which it acts, theta, would be equal to the inverse tangent of our rise over our run, which is 20.9 degrees measured in that direction. So now we want to know if the car is going to make it. If we look in the x direction, we got to figure out how much time it's going to take in the x direction for the train to get to the car. It's got 40 meters that it has to travel, and in the x direction, its velocity is 84 feet per second times the time. It's a constant velocity, so there's no acceleration. The time then is equal to 0.476 seconds, so it's not very much time. The car is going 95 feet per second, so the distance that it can travel is 95 feet per second times 0.476 seconds, which is equal to 45.24 feet. This is greater than the 30 feet, so we know that the front of the car at least will make it to the intersection at the same time as the train, and beyond. If the car is 15 feet long, then the distance that the back of the car is at, or the position of the back of the car, is 30.24 feet, which means that, yes, the car does make it, but barely.